width of the central and secondary maxima in diffraction at a single slit. So in the diffraction of the single slit, we have the central maximum. Again, we have the intensity decreases with first secondary maximum and secondary maximum. So this is the dark fringe. So here it is, we get first dark. So this point is a first dark. This point is a first dark. Then we have a maximum. So this is the central maximum value. So what is the condition? The width of the central maximum and the secondary maximas. So what is the angular width of the central maximum? So the angular width of the central maximum is defined as the angular separation between, angular separation means theta. So the angular separation between the direction of the first minimum. So this is the direction of the first minimum to the central maximum on the two sides of the central maximum. So this is the half central maximum, another half central maximum. This total 2 theta is angular width of the central maximum. This is the angle width of the central maximum. First we have to find theta and multiply by 2, we get 2 theta. So the half angular width of the central maximum is theta is equal to lambda by a. So the lambda is a wavelength and a is a separation. So lambda by a is a angular width of the central maximum. Then angular width of the total angular width is 2 theta. So this is the half angular width. The total 2 theta is multiplied by 2. We get theta which is equal to into 2. So we have to multiply with 2. So theta is equal to lambda by a. 2 theta is equal to 2 lambda by a is the angular width of the central maximum. So what is the angular width of the nth secondary maximum? So likewise there is a waves, primary waves, the maximum wave will goes like this. This is the maxima. So again the maxima will come. So this is the first bright, this is the second bright. Okay. So what is the width of this one? So angular width of the secondary maximum. So what is the angular width of the secondary maximum? Nth fringe. So it may be a 2 minus 1 or a 5 minus 4, whatever it is. So that's why we can take it that theta n plus 1 minus theta n. So bigger value minus smaller value for this theta. So already we have a theta is equal to lambda by a. For this angular width, we get theta is equal to 2 lambda by a. So n plus 1 lambda by a minus n lambda by a. So this is a theta value. So lambda by a is a normal one. For n means n lambda by a. For theta is equal to 1, n lambda by a. Theta is equal to 2 lambda by a. Likewise, here for n plus 1 lambda by a minus n lambda by a. So n lambda by a and here the 1 lambda by a get cancelled. We get only lambda by a is the angular width. So the linear width, so this is the linear width, this length is a linear width of the nth secondary maximum is angular width into the distance between the slit and the screen d. That is beta is equal to linear width is equal to angular width formula is lambda by a and the screen formula is d. So this is the linear. Clearly, we come to the conclusion, this width of this maximum, again the width will be increases and decreases. This width will be determined by this slit width. So, the width of the secondary maximum is inversely proportional to slit width. So, the aperture width, that is the condition. So, width of the central maximum we can find that, and the secondary maxima also we are find that. This is a secondary maximum question. This is a central angular with maximum condition. So this may be asked in 3 more questions, or in problem point of view. These problems are these formulas are very important. Just go through this. And one more thing, as the slit width increases, the secondary maximum get narrower. If the slit is sufficiently wide, the secondary maximum disappears, and only the central maximum is obtained with a sharp image of slit. Thus, the distinct diffraction pattern is possible only the slit is very narrow. If the slit size is bigger, only the central maximum will be there, because this slit width, the secondary maximum slit will be inversely proportional to slit width. If this will be increases, this will be decreases. When the slit width will be decreases, this will be maximum. So that is the condition.